Now let us come to the point if I want to fit a confidence interval for this linear regression. Say the question which I have in hand is that the waiting time is say 80 minutes again, and I want to fit a 95% confidence interval for the mean eruption duration given that the waiting time is 80. So what is a confidence interval? A confidence interval, what it does is, for a given value of x, it finds the interval estimates for the mean value of the dependent variable. Mind you, it is different from a prediction interval which we'll see shortly. So in the case of a confidence interval, what we do is to find the estimate of the mean value of the dependent variable given the value of the explanatory variable. So say that the explanatory variable value is 80. I want to find out the estimate of or the confidence interval estimate for the mean value of the dependent variable. And how can this be done? First, I save the value, the given value in some variable. Say, as I had done before, say new data is equal to data frame waiting is equal to 80. Then I want to predict the value of eruption dot lm given this value. So I write is equal to new data, comma interval is equal to confidence. When I explicitly mention that the interval which I am trying to estimate is a confidence interval, it will give me the confidence interval, the 95% confidence interval estimates. So the result is as follows. See, the fitted value is 4.17 and the lower and the upper bounds, the 95% confidence interval bounds are 4.10 and 4.24 respectively. That means the 95% confidence interval for the mean value of the dependent variable given that the waiting time is 80 minutes is between 4.10 and 4.24. Its estimate has been found to be 4.17. So with this, we've done the confidence interval. Now let us come to the prediction interval for this linear regression. Say again, the question is to find out the prediction interval given a particular value of the explanatory variable. A prediction interval, in contrast to the confidence interval which we just saw, what it does is to find the interval estimate for the dependent variable y for a given value of x. So the difference is to be noted. The prediction interval finds the estimate of the dependent variable y, whereas the confidence interval finds the estimate for the mean of the dependent variable y. So suppose for the same case again, if I have the waiting time fitted as 80 and I want to find the prediction interval for this, I write the same equation, predict eruption dot lm new data interval is equal to predict this time. So this gives me the fitted values and the lower and the upper bounds for the predicted interval given that the waiting time is 80. So this means that for the case when the waiting time is 80 minutes, the 95% prediction interval for the eruption, which is the dependent variable, is 4.17 and the lower and the upper bounds are 3.19 and 5.15 respectively. So with this, we've seen a number of things. First, we had a small data set in hand. The first idea was to fit the simple linear regression for it, and given the value of any explanatory variable, we can find the value of the dependent variable from that particular regression fitted model. We've also seen how to find the coefficient of determination and what it means. We've done the test of significance for this linear regression by looking at the p-values and seeing whether it lies, it is more than 0.05 or it is less than 0.05. Then we fitted the confidence interval and also the prediction interval and understood the difference between both of them. So this is how a simple linear regression is fitted in R. Thank you.